Okay, so this is kind of the third part in a little collection of video lessons about showing simple harmonic motion with functions of this type. And so we're told the particle moves in such a way that its displacement from a fixed point O can be expressed as S equals 8 cosine 5t plus 15 sine 5t, where t is the time in seconds. Prove that it is moving with simple harmonic motion. I'm not going to go through that first part, I'll leave that to you. In order to prove it, your differentiation has to be good. You take the first derivative, which is velocity, take the second derivative, which is acceleration, and show that acceleration is some negative constant multiplied by displacement. That's the definition of simple harmonic motion. So remember, simple harmonic motion, if and only if the acceleration is a negative constant multiplied by, in this case, it's the displacement. Okay, and remember that negative constant is going to be omega squared, negative omega squared times S. So you should be able to find omega from that. Okay, find the periodic time here. In this case, I know for a fact that if you work this out, you should get the acceleration is equal to negative 25 times the displacement. So omega will be omega squared will be 25, so omega here is equal to 5. I know that. I'm going to let you prove it and figure that bit out yourself. Omega is fine. The periodic time, remember t is always 2 pi over the absolute value of omega. That's going to be 2 pi over 5 seconds per period. Okay? The frequency would be the reciprocal of that, 5 over 2 pi periods per second. Find the amplitude, and again in my last lesson I looked at finding the amplitude for functions of this type, and I encourage you just to remember that functions of this type, their amplitude will be the square root of this number squared plus this number squared, 8 squared plus 15 squared. And if you know your your Pythagorean triples, you should know that that is 15. So part B, now periodic time is 2 pi over 5 seconds. Part C, the amplitude here. Part C, the amplitude is 17. Units, whatever they are, we'll just say meters, maybe in this case. So what does that mean? Well, what that means is we have an object that's kind of got an amplitude of 17, which means this is a particle moving between position 17 and negative 17. And remember, the kind of center of those positions called the center of oscillation, and is referred to as having a value of 0 in my position sense. So what we have is an object moving up here from the center of oscillation, slowing down till it gets to 17, stopping, turning around, accelerating towards the center. It hits its maximum speed here, its acceleration will be 0, and then it starts to slow down. Its acceleration will be positive here because its position is negative until it stops. It stops there, velocity 0 out here at the end points, turning back, speeding up at the center of oscillation, maximum velocity, acceleration of 0, position 0, slowing down out here at that point, velocity is 0, acceleration is a maximum, and its position is a maximum. Okay, so we're trying to find the first 3 times that the particle will be at the center of oscillation O, which has position 0. So position 0. So what I'm going to do is kind of try to figure this stuff out. So what I'm trying to do is find the 3 times that the particle will be at position 0. So we're trying to find this D part. Really, what are we trying to find in this D part here? We're trying to find t when the displacement from the center of the oscillation is equal to 0. So I'm going to set my expression for displacement, which is given 8 cosine 5t plus 15 sine of 5t equal to 0. Okay, a couple of things, just making 15 sine 5t the subject. We're going to get 15 sine 5t is equal to negative 8 cosine of 5t, dividing across on both sides by 15. and at the same time dividing across on both sides by cosine of 5t, we'll get sine of 5t over cosine of 5t is negative 8/15. Of course, sine over cosine is precisely our definition for tan. So tan of 5t is equal to negative 8/15. So what does that mean? Well, this means that this particle that moves up and down will be at position 0 when tan of 5 times whatever the time is negative 8/15. So my problem now is just to solve this trigonometric equation. To solve a trigonometric equation, tan of 5t equals negative 8/15. The first thing to do is find the reference angle. Remember where tan is going to be negative here in quadrant 2 and quadrant 4. So 5t is either going to be in here, terminal side in the second quadrant, or 5t will have its terminal side in the fourth quadrant. Because in quadrants 1 and t, tan is positive. The other thing is tan of the reference angle. Remember, the reference angle is to the nearest horizontal. Tan of the reference angle is going to be the absolute value of negative 8/15, which is just 8/15. So I can find out the reference angle here, and I have to do it in radians. We're dealing with radians here, so the first thing I would do is set my calculator to radian mode. And then I'm just going to find tan inverse of 8/15. So I'm dealing with radian mode here. I'm just literally typing this into my calculator. Tan inverse of 8 divided by 15. That's equal to 0.489. I'm going to say about 0.49 radians. All these problems we're dealing with radians, okay? Radian mode. Which means my 5t, if we look in quadrant 3, now remember, pi is 180 degrees, 2 pi 360. So in quadrant 2, 5t, my first time it hits this, my first solution here will be pi, subtract that reference angle, 0.49. Okay? And again, that's something you can do in your calculator. I'm getting about 2.65. Okay? Just typing that into my calculator. The next time will be 2 pi minus that angle in there. So 2 pi minus the reference angle, which I'm going to get as 5.79 to 2 decimal places. That's here. Or the next one will be, 2 pi plus another pi. That's going to be 3 pi minus the reference angle. And I'm getting there about 8.93. Just you might double check. I'm typing this into my calculator, 3 pi minus these things. Okay, so there are my possible values for 5t. Now I just have to find my values for t. So I just divide each of those things by 5 to find my solutions. So 2.65 divided by 5, well, that's 0.53 seconds. 5.79 divided by 5, well, that's 1.158 seconds. And then finally 8.93 divided by 5, that's 1.786 seconds. Okay, so what is cropped up there is the ability to solve trigonometric equations. If you don't know that stuff, you've got to revise it. So I do say at the start of the applied maths course that most people struggle with trigonometry and algebra, and that's really where the problems are. But really you're just solving this equation. You're solving this trigonometric equation, and you're finding the first 3 solutions to that. There's actually infinitely many solutions to that equation. So we find 3 solutions for 5t, we divide each one by 5, and we have 3 solutions for t. Okay? So that's all those things answered. Again, I'm leaving that first section up to you, and that's a little 3-part series of videos. Okay, so practice. 3C, there should be nothing in that section now, sorry, 13C, that comes up that you shouldn't be able to deal with.